Hi everyone, so it's time to do another physics video. So we will be talking about the standards of measurements. So the first standard that we will be talking about is time. So time is measured in seconds. And how do we determine it? How we can determine it is that actually using atomic clocks. So cesium atoms have like certain configurations to transition between one energy level to another energy level. So we bombard microwaves. We bombard the cesium atoms with microwaves, thus giving it energy. And so what happens is that as it undergoes a transition from one of the energy level state to another energy level state, takes a certain time fragments. So 1 second is defined as the time required for precisely certain amount of cycles to be encoded. So the cycles are 9192, 631, 770 cycles of microwave radiations. So when it moves between energy levels, the cycles that we feed the cesium atom is just number. And so what happens is the amount of time is a second, which is the amount correlated to the cycle of microwave radiation. All right. So the next thing will be the length. So length. So we determine the length by meters. So we used to determine it by so actually how we can determine it is the wavelengths of orange light emitted by the excited krypton 86. So from this length standard, the speed of light of vacuum was determined as about 300,000 meters per second. And in November 1983, the length of the standard was changed. Instead of being the wavelength, it is actually the speed of light. We measured the speed of light, and from the speed of light, we can actually measure precisely what meters mean, and then we can use that to define the meters. So how we define the meter is the distance that it is traveled, the distance traveled by a photon in about 1/300,000 of a second. All right, so we measured the distance traveled by using speed of light. So the next thing is mass. So mass is measured in kilogram. So this time, the length first of all is measured in meters. Let's write that down. Measured in meters. And mass is measured in kilogram. And it is defined as a particular alloy. So like we have a cylinder of platinum iridium, and we use a cylinder of platinum iridium as an alloy to actually measure kilogram. So we store that in, let's see, Paris. Okay, so we used cylinder of platinum iridium. And let's talk about unit prefix. So how it's denoted as kilogram. Meters is denoted by M, and seconds is denoted by S, smaller s. All right. So let's write a couple of prefix for like orders of magnitude. So 1 kilometer is 10 to the power of 3 meters, written as 10 power 3, and 1 kilogram is denoted as 1 kg, which is 10 to the power of 3 of a gram, and the gram is denoted as g, 10 to the power of 3 g, etc. So I'm not gonna focus on or actually there is a couple of things that are interesting to say. It's so the observable universe is about 10 to the power of 26 meters. So the observable universe is about 10 to the power of 26 meters. That's A. B is the distance to the sun is 10 to the power of 11. (10 to the power of 11). And the diameter of Earth is 10 to the power of 7 meters. Diameter of Earth is 10 to the power of 7 meters. D, 1 meter is human dimension. And E, 10 to the power of -5 meters is diameter of red blood cells. And F, 10 to the power of -10 is the radius of an atom. 10 meters is a radius of an atom. And 10 to the -14 is the radius of atomic nucleus. 10 to the power of -14 meters is radius of atomic nucleus. radius of atomic nucleus. All right, so I'll end this here, and I will see you guys in the next video. Bye. In the next video, we'll be doing vectors. See you guys.